All right, guys, moving on to chapter 6. We're already pretty familiar with the idea of functions, so we may be able to rip through this one pretty quickly. But there may be some subtleties that we want to find out about. So what is modular programming? That's the breaking up of a program into smaller, manageable functions or modules. What is a function? I call it a named block of code. That's what I call a function. It's a block of code with a name. Well, what's a block of code? It's a collection of statements. So the motivation for modular programming, it improves the maintainability of programs. You can write a module, you can test it, you can make sure it works, and then from that point on, you're pretty certain that that's going to keep working. And if you ever need to fix it, you can probably figure out which module it is contained, and you can make your changes there without too much concern that it's going to break the rest of the program. It's going to change things further on. Simplifies the process of writing programs. So for example, this is a silly example, but what if you had 8 kabillion statements in a row, right? You could break it up. Main has a couple of statements, and then function 2 has a couple of statements, function 3 has a couple of statements, function 4 has a couple of statements. Now really, the main function would then have calls to function 2, function 3, function 4. So this is not quite right? It should say function 2, function 3, function 4. Defining and calling functions. What is the function call? That's when you call the function by its name and you put the parentheses after it, and anything that needs to be, any arguments you need to pass in to fill in the parameter variables you put there. And then the function definition. Those are the statements that make up the function. A lot of y'all have taken Python. A lot of y'all are already familiar with this idea. Let's go in, make our new chunk of code. So we did lecture O last. We're going to do lecture P today. Create a new project. Console app. Then we wait a little while. It finally pops up, right? Okay. So, yeah. I don't care that you updated yourself. Go away. The function call is a statement that causes the function to execute. The function definition is a statement that make up a function. I would reverse these, right? You got to define your function before you call it. Let's define a function. We're going to write a function called sing. It doesn't need to return anything, so I'm going to call it void. It doesn't need to accept any arguments to fill in any parameter variables. Why is that? All it's going to do is print some song lyrics. I love rock and roll, \n, end quote, CIT less than, quote, put another dime in the jukebox, baby. If you're a fan of 80s rock, you're probably pretty familiar with that. That's Joan Jett. Alrighty, I need to add the using namespace std so that I don't have to worry about those. All right, now when I'm ready to sing, I can do that. I'm going to put my system pause here. All right, so what am I going to do here? I'm just going to call. I'm going to do sing, right? I have a Zoom window in my way that you probably can't see, but I want it to go away. Can you please go away? I said, please, can you go away? All right, fine. Finally, it's gone. No, keeps coming back. All right, local Windows debugger. And it print, I love rock and roll, put another dime in the jukebox, baby. What if we like that song so much we sing it 2 times in a row, 3 times in a row? Then when we run it, we see it do that 3 times in a row. I love rock and roll, put another dime in a jukebox, baby. I love rock and roll, put another dime. I love rock and roll, put another dime, right? We could write a function that does that, that makes it sing 3 times in a row. So void sing 3 calls sing 3 times in a row, right? Like that. And so now, if we want to sing 3 times in a row, we can just do this, sing 3, right? So main calls sing 3 calls the sing function 3 times in a row. I'm going to change that to not \n, get rid of the \n, replace it with some spaces so that when it runs, each statement is on its own line, or, you know, on one line. I love rock and roll, put another dime in a jukebox, baby, right? Did it 3 times. We could come down here and we could call sing 3 times, right? Then we're going to see a total of 9 functions, 9 statements in our output. There we go, 9 statements. All right, what if we did not want these to be in top? What if we wanted these to be in a different file? We can do that. I'm going to cut those. I should probably just copy them and cut them later. I'm going to go to source files, and I'm going to make a new file called scene.cpp. So add new item. It's going to be a C++ file. I'm going to call it sing.cpp. And I'm going to paste those 3 statements in it. Now, however, I'm going to have my includes and things like that as well, right? So include all right, why did my brain just freeze on that? IOStream, okay. Done too much C programming today. IOStream, right? And we need our using namespace, or we need to replace these with std::. I'm going to do that just to look like a real grown-up C programmer. There's nothing wrong with using namespace, but a lot of people recommend against it because if you have multiple include files coming in, then if you include multiple files and then you do using namespace, then you're bringing in a whole bunch of baggage with them using namespace that you might not want. It's making a whole bunch of things accessible to you. All right. I did not need to put std::, here, right? Because these are not cout commands. That was my mistake. Okay. So this one's ready to compile. But we have an error here. Sing3 is undefined. Here's one way to fix it. I could just declare a prototype right here. But that is really lame. Why is it lame? Because each file I create that needs to call the sing3 function would have to have its own prototype in it. What we really want to do is use a header file. We're going to make a header file called sing.h, except we need to put quotes around it because it's in the same directory. Our own header files go with quotes rather than angles. And now I need to make a file that actually matches that, right? So I'm going to come over to header files. See the header files? Right click, new item, and call it sing.h. Did I capitalize it or leave it lowercase? I left it lowercase, sing.h. And I just need to put the prototypes in there. I'm going to ignore for a moment what pragma once means. And this is void sing3. Why not define the other one too? Void sing. So what is a prototype? It's just the function header but with no body, no code body, right? So these are prototypes for functions in sing.cpp. And so any file that needs to use the sing functions can just # include them, right? That way we could have, 2 prototypes in there, or we could have 100. What if we had 100 different functions in sing.cpp? Well, they would all come in, all the prototypes would come in if we do # include sing.h. And we're going to confirm that this still works. And it worked just like it did before. Very good. This is a very common thing to do, and I should be encouraging you to put different bits of functionality in their own files and then create header files with the prototypes. So when you're declaring your function, you give a return type. Didn't have to do this in Python. You give a return type, you give a name to the function, and you put some parentheses. Inside the parentheses, you put the parameter list. Well, in this case, the parameter list is empty. This is defined as an int, so it can return a value. It can return a value to the operating system. So if you wrote a batch file, a CMD file or some kind of script that called the executable, it could check the return value to see whether it succeeded or not, to see what it returned. And this is the function header, right? And this is the function body, statements between the curly braces. So if a function returns a value, the type of the value must be included. Int, string, double, long, that kind of thing. If a function does not return a value, its return type is void. If it doesn't need to return anything because all it's doing is printing rather than performing a calculation, it can be declared as void. So when you call the function, you just use its name, you use the parentheses, you fill in any arguments it needs to fill in the parameter list. Apparently this print heading has no parameter list, right? So when we were ready to call it, we didn't need to put anything in there. And then when called, the program executes the body of the called function, executes the statements. After the function terminates, execution resumes, right? So if we're looking at our code, when we call sing3, it jumps into the code defined over in this CPP file, right? Runs it. It finds that one, so it jumps into sing, it executes these statements, and then it returns, and it's ready to execute the next one. Same deal, it jumps into here, runs those 2 statements, returns, and it comes to here, it does the same thing, right? It calls this function, executes these 2 statements, returns. Now it's done with all 3 of these, so it returns. Notice I don't have this word return here. There's nothing wrong with putting the word return on a void function, but it's not necessary. Makes it look kind of nice, maybe. On the other hand, maybe you don't like it. You certainly don't have to put it, and the standard is, I believe, not to put it unless it has to return something. If it's defined as anything other than void, there better be a return statement. And so when it returns from sing3, execution then proceeds to the next line. And then it does all that again. Then execution returns here and it does all that again. And it comes here and it executes this function. Well, this function is given to us by the C++ libraries. We didn't create it. I wonder if we go to definition and see what it looks like. All right, it's pretty complicated. All right, get rid of that. So this program has 2 functions, main and display message. It's got display message, and it's got main, which calls display message. So it prints out hello from main, it displays our message, and then it displays another message that says we're back, and then it returns. So the flow of control. jump into main, do that, call display message, which causes it to jump up here, executes that line of code, gets here, which causes it to return. So it can just do that line and then return out of that function. We're done. So main can call any number of functions, right? Main could be 1,000 lines long. You're generally not supposed to do that. Each function you write, including main, should probably be no more than a page or two of code if it was printed out. Functions can call other functions. The compiler must know the following about a function before it is called. If the compiler doesn't know the name of the function, its return type, its number of parameters, and the data type of each parameter, it can't compile. That's why we got an error message before we had declared our prototype. So if we just write a function call here, display message, right, like that, it's not going to compile because it doesn't know what it would return, if it took any parameters, what kind of data those parameters needed, right? So needs all those things. And it doesn't matter if we actually have that function defined somewhere else, right? I could write one, void display message, right? It's not going to even do anything. He still can't compile until he knows those bits of information. He needs a prototype for it. So I could go to sing.h and create a prototype for that as well. So in sing.h, I'm going to add one more prototype for display message. Then it can actually do something, right? Why don't we make that method, that function actually display something? So cout, look, a message, \n, end quote, semicolon. Oops. Now I'm beginning to wish I had done # include or using namespace std, right? Or I could have just done std : there. That would fix it so I didn't have to have the using namespace. And now that lecture P knows that information, the compilation error goes away. The compiler now knows what data type display message returns. It knows its name, and it knows what kind of parameters it needs. And this one doesn't need any parameters, so we're good. If we make a mistake and we try to pass in an argument to fill a parameter that doesn't exist, we're going to get an error. It says too many arguments in function call. Too many arguments, why? Because he didn't want any parameters. And we can make it accept a number. Maybe we could make it repeat that many times in a row, right? For int I equals 0, I is less than x, I plus plus, right? And then print that message that many times, right? So if we go over here, we could print that message out 10 times if we wanted to. However, it's still giving me the error. Why? I added that parameter to sing.cpp, right? However, I never changed it in sing.h. I have to make sure the prototype must always match the way the method is defined. The function is defined here. I'm sorry, in Java, they're called methods. And in C++, they're called methods if they are attached to a class. Right now, nothing is attached to a class, so it's just a function. So I need to make this thing take. I need to let the compiler know that he wants an integer. I don't even have to give it a parameter name, right? That's enough to tell the compiler that it needs an int to fill that parameter in. And you'll see a lot of people do that, just fill in the name and not give the parameter name. I like parameter names, right? Parameter names can have useful information, right? Like number or repeats, right? That tells you something about what display message does. It repeats some message a certain number of times, right? That's useful information. Now that doesn't happen to match how I defined it over here, but that's okay. I could do that. I can make it match, right? variable names aren't as important in terms of prototypes because the prototype just has to know what the data type is, that it was an int. As far as the prototype is concerned, the variable name is superfluous. But like I said, I think variable names, whoopsie, that's wrong. That's the one that got changed, right? But you know what? After all those changes, I'm going to show it the way the book does and just leave the variable name, the parameter variable name off. Now what are you complaining about? Maybe I need to recompile it and it'll fix everything. Hope that's the case. Yeah, all right. Sometimes the editor doesn't realize you've made a change, and so it keeps showing something as an error. Light bulbs like this one shows you potential fixes. Create a declaration definition. What are you trying to do there? Well, that didn't do a darn thing. I don't know what that error message was, but it fixed itself. All righty. Just to prove that it still works, I'm going to run it again, and there we go, right? Look a message. It printed it 10 times. Function prototypes, we've been talking about them. If the header for the function looks like this, of course, it'll be followed by a body on the next line, right? There'll be some kind of body attached to it. Then the body of it looks just like the header, except it has a semicolon at the end rather than a body. So here's our prototypes for two functions called first and second, right? It needed the prototypes, otherwise it would not be able to compile because the compiler wouldn't know what first was supposed to return or what parameters it expected. Same for that one. Now, why would you do that? Because apparently these functions are defined somewhere else. They're probably defined underneath main, but they could be in a different file. And if we scroll down to the next one, we'll find out that yes, indeed, they were defined as part of the same file as main. So you tend to place your prototypes near the top of a program or in a header file. It's even better to put them in a header file if you're spreading your code across multiple .cpp files. And the program must include either the prototype or the full function definition before any call to that function. Now, that's not true of Java. You can list your functions, you can list your methods in whatever order you want. But in C++, if I'm going to call sing had better been already defined, either as a prototype or the actual function. Same thing over in main. Display message had either better be defined before main, or at least the prototype had better be defined. And since the prototype was stored in sing.h, indeed it is. Sending data into a function, that's what the parameter variables are for. You can pass values into a function at the time of call. For example, the good math function POW. We pass in two numbers. These are called arguments. Whoever wrote the POW function made it accept two parameters, and so we have to pass in the arguments. So the variables that you pass to the function are called arguments. The variables in the function header definition are called parameters or parameter variables. And some people call them different words. Some people call them formal parameters and actual parameters or something like that. You'll see those words in some books, but this is pretty universal as well, calling them arguments. It's real easy to slip into the habit of just calling these parameters, right? I'm going to pass in two parameters, A and B. You'll hear me say that, but it's more correct to call them arguments. It's not quite correct to call these parameters, but we know what that means. Just like it's not correct to call a pterodactyl a dinosaur. It lived in the time of the dinosaurs, but technically speaking, for some reason, it wasn't a dinosaur. Well, technically speaking, these are not parameters. These are values that fill in the parameters, and things that fill in parameters are called arguments. So here's a function called display value. It wants a number. It's got a parameter variable called num. So when it is called, hopefully on the next page, when it is called, we need to pass in an integer of some kind. Either a literal value like that, like 5 right there, or a variable that can be translated into an int. Some kind of int has to go into display value right there to fill in. So some kind of argument has to be put there between the parentheses to fill in this parameter variable. Display value accepts the integer. When we call it with a value of 5, that argument fills in that parameter variable. And I don't have to call it a parameter variable. I could just call it a parameter. So a parameter can also be called the formal parameter or the formal argument. An argument can be called the actual parameter or the actual argument. Well, forget all that. We're going to use the common terminology. So for each function, the prototype has to include the data type, what it's going to return, void or whatever, the name, and inside the parentheses, it needs the data type of each parameter. So even or odd takes an integer. In the header, we have to give that parameter a variable name, right? But in the prototype, we don't. I've already mentioned that. Again, I don't see why not put the parameter variable name inside the prototype. It's legal to leave it out, and you'll see a lot of programmers do it that way. So the value of the argument is copied into the parameter when the function is called. And the parameter scope is the function which uses it. In here, go back, we've talked about scope before. Where's our function called display message? It's right here. This variable scope is for all the body from there to there, just like if you declared a variable here, well, for whatever purposes, right? XXX is a local variable that exists from there to there. Well, this is also a local variable that exists from there to there, meaning that I can't access repeats from down here, right? I can only access it between the braces of the body of the block of code. I'm deleting that, don't need that. So parameter is local, is a local variable that whose scope is the body of code there, the block of code. Functions can have multiple parameters. They sure can. There must be a data type listed in the prototype and an argument declaration in the function for each parameter. So if I add a second piece of data, come on here, and I feel like making this an accept a string, which is our message to display. Now it doesn't know what a string is, so I'm going to have to do # include string as well. Right. And then in the header file, I'm also going to have that I need to add this change as well. You're going to compile for me, pretty please? String is undefined. Okay, forget it. I am going to do the using namespace std. I could have fixed that by putting std : in front of the string. Now we're winding up with a lot of header files that are necessary in order to use this string.cpp file. We could have put them right here. I guess I'm not gonna. But anyways, display message now requires 2 arguments, one the int and one the string. And here we go again. It doesn't know what a string is. fine. I'll give in # include string, and then using namespace std. Now this is a horrible thing to do. We really should not add using namespace std to any header file. Please just accept it on faith that you shouldn't. So I'm going to fix this call to string here, the correct way to do it. And I guess if I keep doing it the strictly formal way of doing it, I may as well get rid of that and fix the calls to string here as well, right? Now lecture.cpp won't compile anymore. Why? Because display message needs two arguments, and we've only got one there. I know I've said this before, but never choose yes, I'd like to continue and run the last successful build. And for heaven's sakes, never choose do not show this dialog again and then choose yes. Because then it'll try to run it whether it had an error or not. You won't know that there is an error. No, please don't. Okay, so I'm a little teapot. That's going to be my message. I'm a little teapot. End quote. Now, I did not actually modify the thing to display that message. So I'm going to go back to my CPP file and sing and do that. So instead of saying, look, a message, it's going to see out message ~ENDL. And I'm going to have to put std : in front of that as well, since I don't have the namespace. All right, now we're back into a working code. So pretty much any function I add, I have to go and add to the header file as well. And there we go, I printed out I'm a little teapot 10 times in a row. If we were looking at this header file, wouldn't it be nice to know what the int was and what the string was? I think it would be. So if we had these variable names here, the number of repeats and the message to be displayed, I sure would be happier to use it. So when calling your function and passing multiple arguments, the number of arguments needs to match the prototype and the definition of the header. Just have to pass in the same number. There are exceptions. You can have parameters that have default values, in which case when you call them, you don't have to fill it in. So for example, I'm just going to make a silly function called test, and it accepts an integer. However, x has a default value. And then I'm going to see out a message. Testing space, end quote, x, not end quote, error, error, x, error, error, ENDL. Right? And so when I call test, I could either pass in a number, and my keyboard confused me there. I could either pass in a number, right, like that, and now it's going to print testing 10. The 10 is going to fill in the x parameter. Just like that, testing 10. But if I choose to leave this off, it's legal for me to do that because he's got a default value there. So what if I wanted to put this over in sing.cpp? Then what I would probably want to do is to remove that. I'm going to grab this. You know what? I'm just going to leave that alone. But the question becomes, how do you define it in the header file? Well, I'm going to go ahead and define it in the header file. Void test int x equals 3. And I'm going to get an error. It's not going to let me compile this. There were errors. I don't know why it says no issues found. But if I find the error list, view error list, we will see it say the redefinition of the default argument. So I could put the default argument here, or I could put it here. I think that's the case. I need to remind myself. What happens if I remove the default argument here? Will it suddenly compile? Now, in my mind, it shouldn't compile. Why do I say that? I need to do something in order to continue to test this. I need to actually cut this and put this in the sing method, or at least underneath main. How about just underneath main? So that it is not defined above here, right? So now the prototype for it is defined in sing.h. The actual function itself is defined here. We have a default argument value here. There is no default argument declared in the header file. When I run, is it going to work? And no, it's not going to work. Why? Let's look at our error list. Test function does not take 0 arguments, right? We didn't pass in an argument there. Why did it expect us to pass in an argument? Because the only thing it knew about the test function was what it found out in sing.h. And in sing.h, it's saying that there's no default value. But I could put a default value there. If I was going to do that, I would have to remove this one, because you can't have the default value defined in both the header file and in the function header. You can define it in the prototype. That's how you should do it, is to specify the default value in the prototype, but not in the function declaration. Now to compile again and run. So when it runs, it says testing 0. That's when I don't pass in a parameter, an argument. But if I come up here and pass in a number, it will print out testing 99. Testing 99. Oopsie, come back here. So when we call the function, we want to pass in value 1, value 2, value 3, and those variables fill in the values for parameters num1, num2, and num3. Passing data by value. C++ does both what's known as pass by value and pass by reference and pass by pointer. And what does all that mean? Well, when we write a function, like up here, I'm going to write another one called test2, void test2, and all it's going to do is see out, let's put a variable in here, int x. It's going to see out the words testing, end quote, less than x, less than endl. And so let's call test2. The number 1, 2, 3, 4, 5, 6. That'll be real obvious, right? We'll see that message be printed. All right, and then 1, 2, 3, 4, 5, 6. This value, this argument gets copied in to that variable. And that makes sense, right? Well, you have these numbers, they get copied in there. What if it was a little more subtle though? What if we had a variable called x here that had 1, 2, 3, 4, 5, 6, and then we passed that in? What does that mean? Is this variable the same as this variable? Well, it has the same type, it has the same name, but it's not the same variable. This value gets copied into this variable, but they're not the same variable. This is just a copy. It's like I photocopy my check before I hand it to you. then you can't tear up my original check, right? I still have the original check. So even if this function changes that value of that parameter variable and makes it negative 1, 2, 3, 4, 5, right? Down here, it's still equal to positive 1, 2, 3, 4, 5, 6. So if I do after test2, x equals, in quote, less than, x less than, ENDL. Well, before it was called, it equals 1, 2, 3, 4, 5, 6. And after the call, it still equals 1, 2, 3, 4, 5, 6. Because although this changed the value of the parameter variable, it did not change the original variable. The parameter variable just received the value of the argument. It received a copy of it. So that's what pass by copy means. It copies the contents of that x variable or that whatever number we had in there previously into this variable. This variable scope is from here to here. So any changes to that variable are limited to that brace there. That block of code there doesn't change it here. So when I run it, I'm going to make this say before test 2 and then after test 2. We're just going to see that it's the same. Right, so before test 2, x equals 1, 2, 3, 4, 5, 6. That function tried to change the value of it to negative 1, 2, 3, 4, 5. And it did for the scope, but then it's still 1, 2, 3, 4, 5, 6. So if I change the order of these statements, right, if I move that one up above it, it'll print out testing and it'll print out negative 1, 2, 3, 4, 5. But everything else is going to behave the same way. All right, so after test 2, x equals 1, 2, 3, 4, 5, 6. Before test 2, x is 1, 2, 3, 4, 5, 6. But in that function, that variable now has a value negative 1, 2, 3, 4, 5. So this variable here, right, and that variable here are not the same variable. This one is just a copy of it. So the mere fact that it has the same name doesn't matter, right? That's why I say variable names don't matter. You know, if I called this one XYZ, as long as I also called it XYZ here and XYZ here, it'll work just as well, right? Some people get annoyed when you're passing in a variable like this whose name doesn't match that one. But these names have nothing to do with each other, right? This is just a photocopy of this. It doesn't matter if the check has my name written on the back of it, or when we give you the copy of it, if you write your name on the back of it. Okay, that's probably a stupid simile. Anyways, the names don't matter as long as it's just used consistently. This parameter variable has a different name than this argument, and that's totally cool because this parameter variable just gets a copy of x. All right, that may be about the end of that lecture. We may want to stop there. So we made it to page 33. We're halfway through the lecture, actually. Using functions in menu-driven programs. I think we already did this, right? We made a program where you do the sphere size, right, and the material. We already know how to use functions in a menu-driven program, except we didn't make that program work with functions. I said I was going to stop, but I didn't. But yeah, let's go ahead and stop there, and we'll revisit that topic. Alrighty, so no homework over this particular idea, but when we come back in for the next lecture for the week, there will be homework based on the idea of functions. All right, contact me if there are any questions, and I'll see you or you'll hear me next lecture.